Oh, hi everyone. Thanks for joining our first office hours for AI Studio and trying to get you uh, the help that you need in order to get set up and active in AI Studio and answer any questions that you might have. So today we're joined with John Anderson, and John is one of our AI engineers. He's the top dog at Quiq, and does a lot of our AI development. And so John's going to take you through a couple of the questions we've received and help you to better understand the tool and give you some tips and tricks of what you can do. And then we will meet back again in another week for additional questions. So I want to remind you that the way that you ask questions is to send us a heads up in an email at aistudio@quiq.com, and we will take those questions. We will include it into our planning, and then we will showcase those answers and results after during the next office hours session. So we thank you for joining, and we hope you find this very useful. John, why don't you go and take it away?
All right. Thanks for being here with us today. I am going to just kind of jump right in a demo tenant here where we can see some actual conversations going on and kind of answer some of the questions that we've gotten. So a couple questions came in. What's the best way to ask an LLM for a few different things? And another question that'll end up being related is how can I save on processing time or inference time? How can I make it faster? Those two questions might seem disparate, but at the end of the day, we're going to use a strategy that's going to help with both. And so I thought I would kind of group those two questions here together. What I'm going to say is something that you might have heard us talk about before, but parallel atomic prompting is kind of the answer to or the solution for both of these issues, right? So parallel atomic prompting, what does it mean? It's we're going to ask the language model to break things down into single tasks. We're actually going to break it down into single tasks, and we're going to ask the language model to solve for each of those tasks just one at a time, but not one at a time, sequentially one after another, but we're going to actually do them in parallel. So if I have 8 tasks here, I think I'll show you this here. I have, I don't know, 9 or 10. I'm going to run them all at once. So it is 9 or 10 different calls to a language model, all happening at the same time, so that if the longest one takes 1 second, they're all done in 1 second rather than 1 second followed by 1 second by 1 second. So by breaking those tasks down, asking the model to do, or a model, and we'll get into that in a minute, to perform a task and give an answer, and doing it all at the same time, we save on inference time. So there's where that comes in, right? Because we're doing it all at once, and we are asking the model to do a specific thing rather than a whole host of things. So you can think of it like sometimes you want the language model to be able to answer a question from a user, right? And you want it to answer it, except you don't want it to talk like a pirate, as a common example, right? Or you don't want it to talk about your competitors, or you don't want it to address things from certain topics. But if you start to tell a language model all these things, here's the knowledge, here's your guidance, here's the things I want you to say, here's the things I don't want you to say. Also, don't talk like this and only answer questions about this topic, or this topic. It gets to be a lot. You're kind of asking, if you thought of it in terms of you ask a person to do all of those things, they're probably going to forget some. And not that a language model works exactly the same way as a human's brain does. I know that that's obviously not true, but you can think of it like that, right? If I ask you to do 10 different things at one time, you're probably going to forget one of them, or you're going to like slip on a couple of them, or they're not going to be as good. Whereas if I ask you to do one thing, you give me an answer. I ask you to do another thing, you give me an answer. You're going to perform those tasks much better. So that's what parallel atomic prompting is all about. So if I take a look here, this is a demo that we have for a bike store, Quicksilver Bikes. Truthfully, the business here isn't so important. What's important is just looking at the way this happens and this works. So somebody comes in to the chat and they say, or we can actually just do it here. What if we I'm just going to say, I need to check on when I can pick up the bike. And what I'm saying here isn't super important, but what I want to show is the prompt or the parallel atomic prompting, kind of that strategy. So here's the event that just happened over in our debug workbench. And what I can see is that the question came in, I see the response ultimately that the agent gave back to the user. But in this first node that we're really getting into the meat of things, we're classifying the question. And so to classify the question, and we'll get into some of this more advanced stuff, I'm sure, on other office hours, I'm setting and unsetting some fields here. But what the meat of this is, these are the prompts. So I'm asking a language model, what next step should I do? What's the search topic? Is this a sensitive conversation or not a sensitive conversation? Is it in scope or out of scope for my business? And by asking each of these things individually, I get an individual answer that I use to then build up the prompt pipeline as we move down. So as I get, I'll close the conversation here. As I get further down the pipeline, and this gets, looks complicated. We're not getting into all of that, but I'm going to build up the component pieces that I'm going to use to inform my conversation as it moves along that pipeline. So if I determine that the topic is, order pickup, I might do something specific with that. If I decide that it's a sensitive topic that somebody says, I'm going to sue you, what am I going to do with that? So by asking the model to break down each user utterance into its component parts and see what's happening, we can then use those components to guide and inform the conversation as we move along. So I'll just show you, maybe we'll look at next step here. And next step is a reasoning statement or a reasoning prompt. And we're asking the model here. We won't get into the real specifics here, but we're asking it, what's the next best action? What should you do next, given this set of guidelines? And then I'll get out of the prompt and I'm going to show you in the event what that looks like is that we've asked it, here's our conversation, here's your job, pick the next best action. We can get into prompting techniques and all of that another time. But ultimately what I've done is I've gotten this next best action of find information, right? So we're basically asking it, do you want to find information, escalate to a human, or acknowledge somebody saying something like hi or bye or thanks. And so I'm going to set a field with that completion. I'm going to set a field for find information, and then I'm going to route my conversation based on that field. And so by doing this, by taking every individual task and breaking it down and asking for a singular answer for a given task, we can use those to guide the conversation. So a long-winded answer perhaps, but the best way to ask the LLM to do multiple things is to ask it individually. That's going to save on processing time. It's going to have a whole host of benefits. There are, if you think about all of the language models available to us today, different models have different strengths, right? So by breaking this down into 9 or 10 different prompts, I can also come in here and I can just switch the model. So like if I know that any number of these models is better, maybe Gemini Flash is better at the next step classification. I've determined that over time as I've worked with more models, or maybe Claude is better at determining the topic. These are kind of silly examples because I think all models would do really well with these upfront tasks. But later on, when you get into different tasks in the pipeline, you will likely find that some models perform better on certain tasks. So by breaking your prompts down, you're going to be able to not only have them run faster, have them run more specifically, but also choose the best model for a given task. So that would be my highly recommended prompting kind of guideline strategy for how to handle kind of everything that you're doing with an LLM. An LLM is a tool that we use here to process things, and so just try to process them one at a time. I think one other thing, this is vaguely related in that you'll see here we're getting structured output. So one question we have is just like, how do you get consistency from a model? So there's a number of ways to do that. And a number of ways that question could be interpreted. The more specific you are in the guidelines, the more consistency you're going to get in your answers. But then, but very specifically, one thing you can do is ask for structured output, JSON output in this case. And by doing that, I get key value pairs, right, that I can use, and I can key into this next best action key and get find information and set a field. So by using here, we're using GPT-4o Mini, and by doing that, I can get structured output that I can use specifically to set fields or whatever that might be. But again, by knowing what I'm going to get back, or knowing about the at least the structure of what I'm going to get back, I can then build up those component parts that I'm going to use throughout the pipeline. You see here, we're also asking for a reasoning statement as well as the kind of information that we're actually looking for. That's a little bit of chain of thought prompting, right? We're asking it to reason or to give a brief step-by-step explanation. What we're doing is we're kind of priming those tokens to be used in a way that helps the model get to the answer that we want it to get to. So again, that structured output has a number of benefits, not only output consistency, but it allows for some chain of thought prompting right there as well. And then let's see. I've got another question here. How do you build or change things? There's a couple questions about this, and I've kind of combined them here. So let's say I'm building, and 3 months from now, I want to update the model. 4.5 mini comes out, or a new Claude model comes out, or maybe you just add new knowledge to your database, and you want to make sure that the changes you're making kind of they don't break what you've already built, right? And so I think early on in prompting, a lot of it was based on feel. You kind of you prompted and you built this thing, and it works, but then you test it and like this one little piece doesn't work, and so you continue to iterate. But how do you ultimately know that what you're building now didn't break what you built before, or that it's still performing the same way you want? And the answer to that is just it's tests. So I've got a few tests set up, and we can think of it in a couple different ways. We want end-to-end tests. So user says this, AI agent says, has this response. Ultimately, that's what we want. That like this whole thing is built to get a specific answer to two questions. And so we can build test sets. We can say, here's a real conversation that happened. Let's go to this one here, this check on order. And we can say, I'll run this here for us. I can build, I'm in a different version of the assistant right now. Sorry about that. I'm in a draft that I broke a little bit ago as we're building. But what's going to happen is, and ultimately we can see that the assertion didn't hit here, which honestly is really useful. So something is broken right now, and that assertion didn't hit. But you can see right here that I have an assertion built on the final answer from the model. So this person, they came in, they wanted to check on their order, and the assistant or the agent said, I understand you're eager to check on your bike's pickup status, but I'll need you to sign in so I can assist you further with that. And all we're saying is, hey, every time that somebody has this type of question, we want this type of answer. And we're using a model purpose tune to be able to compare the two. But not only end-to-end tests, I want tests on things like, did I get the inquiry type? It's sales versus service. So for the bike example, is somebody contacting me about, a punctured tire, or are they contacting me about picking up, the new seat that they ordered? So is it sales or is it service? It is one of those kind of classifying questions that we have here. You can see we have a prompt around it. And so all I've done is built a whole host of tests around when this conversation runs, did I correctly classify it as sales or service? We build those assertions on there. And then what happens is you make some changes, or maybe you add, you've got sales and service, maybe you add a touring division of Quicksilver bikes, right? And so now you need to know whether somebody's asking about sales, service, or signing up for tours. And so in doing this, I can add in some prompting around tours. I can add a knowledge around it. And then at the end of the day, I can run all these prior tests. I can make sure that I'm still getting all my sales or service inquiries correct. And I've known that adding in touring did not negatively impact anything that I've built previously. So I think of tests in two ways. One, end-to-end test. User puts in this, we're going to consistently get back an answer that semantically matches the kind of approved answer. And then the other component of testing is building up, just like we do parallel atomic prompting. There's probably something to call this, but we're basically testing all of the component parts as well. And so that if my end-to-end test doesn't pass, I can then go in and look at all my component part testing and see what thing is in need of some help or in need of some work to get it to work as well. So by testing end to end and the component parts, I build up a host of tests that I can run. I can see those now when I'm not in a draft that I'm working on, I can see those green check marks here. And not to say that no draft will have green check marks. It just happens to be that I've made a breaking change here a little bit ago. You'll get a bunch of green check marks that show you that things are working as expected and that your build has not been negatively impacted by anything that you've done. So I know that I feel like I've talked a lot here. Those are the questions I have from today. I don't see any new questions out, so I will just put out this reminder that we'll be back here next week. For any questions that you have that you want us to cover next week, aistudio@quiq.com. Send those in. We'll take a look at them. We can help go back and forth if there's something real specific. We will anonymize any questions that come in. It won't be specific to your business, but we can cover the topics and kind of strategies to help get you all what you need. Thanks for coming by today.